everyone. Today is Monday, March 27th. Wow. And can you believe it's already the 10th week? We have a new attendance sheet. So, Okay, so today we will finish 3.4 and then we will start 4.1. Okay. And your exam 2 is next Friday. Okay? And when do you want to have the review session to be on? You like it on Wednesday or Monday? Monday. Okay, let's vote. If you like to be on Monday, raise your hand. Wednesday, raise your hand.
Oh, I wanted Monday because I'm going to take my test on Wednesday.
Okay, but more hands on the Wednesday. So, okay, let's have it on Wednesday. But because we're so close to our actual exam, make sure this time, promise me, you really finish it before Wednesday. And you promise? Finish the practice exam and use the red pen to correct it before you attend the review session. Because when you attend the review session, you can ask me questions, and then we go over the problems slower. Okay, everybody? So yeah, make sure you finish the practice exam before that. Hi. And do you have an exam 1 formula sheet? You might have it. And is exam 2 formula sheets? Okay. So let's continue, right? Let's see. This week you have homework 7 and quiz 4 on Friday. Okay. So your exam 2 cover chapter 2 and chapter 3 and section 1.8. So that means 4.1 and the 2.7 and 5.1 are not in your exam 2. Okay? Right. Because we still need to cover new things when you're reviewing the exam, right? Okay, so let's see. Last time we talked about the rational zero theorem. Okay, so it says that if we have polynomial of degree n, and if the polynomial has rational roots, then the rational roots must be in the form of p over q, where p is the integer factors of the constant term, and q is the integer factors of the leading coefficients. Okay. And if you missed some class, please make sure you watch the lecture video and take notes. Okay? So last week, several of you signed up to meet me, but you didn't come. So I really hope that you can meet me weekly. We only have 5 or 6 weeks left, right? So you really want to pass this course, right? So please do all your best to improve. Meet me weekly so I can make sure you are doing your thing. I'm pushing you, right? Because at the end, your grade, your performance decide what grade you get, right? You saw the grading scheme. It depends on your homework, your quiz, your self-assessment scores, and your actual exam scores. You can use your final exam score to replace one lowest midterm score. And I hope your exam 1 is the lowest score, which means your other exam a higher score. So if you work hard and do well on the remaining exams, you can still get an A, okay? But you need to work hard and do well on those exams, because if you didn't do well, if you don't do well on those exams, there's nothing I can do, because the exam is there, and then I graded based on, you saw the solution, right? Yes. So I cannot make up the scores. Your performance decide what grade you earn. So what I can do is, you tell me how I can help you, what resources I can do for you. So I give you notes with answers, I give you review session, I give you formula sheets. These are the things I can do for you. But we still need to, so our course, we have a lot of objectives. We still need to cover those objectives. I understand, you might think we covered so fast. That's because we have so many objectives that we need to cover. But I'm already trying to slow it down a little bit. Now you see we cover less examples, right? And I asked like everybody to take turns to answer my questions to make sure you are following. But if you miss some class, please watch the lecture video, and also if you have questions, come to ask me. Okay, everybody? I need all of us. We need to work hard to help you. Okay. So, example 1, right? We find the integer factors of the constant term. You always start with plus or minus 1, and then this plus or minus 3. Integer factors, so no fraction here, just integer factors. And then you look at the integer factors of the 4, which is plus or minus 1, plus or minus 2, plus or minus 4. And then possible roots will be using these numbers divided by these numbers. So you look at each pair, right? 1 over 1, 1. 3 over 1, 1. 1 over 2, 1 half. 3 over 2, 3 half. 1 over 4, 1 fourth. 3 over 4, 3 fourths. Right, everybody? So you have 12 numbers, but this is a polynomial of degree 5. Degree is the highest power in the polynomial formula, right? So that's why the degree is 5, which means we have at most 5 roots, okay? And we have 12 numbers. So that means not all of those numbers are roots of this polynomial. So how do we tell whether a number is a root? By the factor theorem, okay, that we learned last time. You put that number into the polynomial. If you get that number, p of that number is not 0, then we have that number is not a root. Okay, everybody? And if that number you plug in p, you get 0, that means that number is a root. Then x minus that number is a factor of the polynomial. Do you remember that, everybody? So if you missed the class last week, please watch the lecture video, step by step. Make sure you understand it. Okay, so sometimes students ask me, what can I do to improve and get past the course? Be able to understand every problem in class. You know that our exams, we ask problems that similar to the in-class examples, right? Right? Yes? So make sure you understand every example in class. Okay. All right. So we know x minus 2 is a factor. How do we find the other factors? Okay. Review attendance sheets. Oh. So we use long division or synthetic division, okay? And long division works in general, no matter what the degree of the divisor is. The synthetic division only works on the form of the linear divisor with the coefficient of x is 1. But in this case, x minus 2 is in that form. So we use synthetic division, it's easier. And you always get the remainder is 0. So therefore, this corresponds to 2x squared plus 5x minus 3. And you see, this is a quadratic factor. Can we factor further? Well, you either factor it or use the quadratic formula. I know some students factoring. It's okay, you can use the quadratic formula. You don't have to do factoring here. Okay, so you can use quadratic formula and find roots. And in this case, it's degree 3 polynomial, so we have 3 roots. Okay. All of them has multiplicity 1. Okay, and this is when we have degree 3 polynomial. We use rational zero theorem to find 1 root, then we can do the division. If you have degree 4 polynomial, you use the rational zero theorem to find 2 roots. And then you use the long division to find the remaining quadratic factors. Okay, everybody? So Last time we did polynomial of degree 3. Today, let's do polynomial of degree 4. Okay. So, example 3. All right. So this worksheet is the same as last Friday's. Yes. Okay. And let's start with the constant term. Okay. So we put factors of the constant term is 10. What are factors of 10? Kristen. 1, 2, 5, and 10. Very good. And then we look at factors of the leading coefficient. Do you see the highest term is x to the 4th? So the coefficient is 1, right? And factors of 1 are just 1. Yes, everybody? Because it's, oh, this is the highest power. And the highest power that you factor out? We don't factor out. Okay. So the process is you look at the constant term, which is 10, and then you look at the leading coefficients. Leading coefficient is the coefficient of the leading term. The leading term is the highest power term. So the highest power term is x to the 4th. Then the coefficient of it, do you see, we don't have any number here. That means the coefficient is 1. Okay? And then we find the factors of 1. You always start with plus or minus 1. So in this case, just plus or minus 1, right? And then possible roots. So possible roots, we use these numbers divided by those numbers. And you can see anything divided by 1 is happening, right? So we just have plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. So far, so good, everybody? Okay, now let's try. This is degree 4. So we use the rational zero theorem to find how many roots? 2 roots. Okay, everybody? Use the rational zero theorem to find 2 roots. So let's try 1. Okay, we plug in 1. We plug in 1, x is 1. Then do you see here we have 1 to the 4th minus 5 times 1 to the 3rd minus 5 1 squared plus 23 times 1 plus 10. Yeah, everybody? Can I just put 1 instead of 1 to the 4th to save time? Can I do that, everybody? Okay. And minus 5 times 1 squared. Can I just put 5? Because 5 times 1 is 5. Can I do that? And then plus 23 times 1 is 23 and plus 10. Of course, it's not 0. Because I got a lot of positive number and the main number is too small. They don't cancel out. Right, everybody? So you don't have to calculate what this is. You just need to know whether it is 0.
Yeah.
Oh, I missed that. Oh, sorry. Yes, I missed that. Thank you. Okay, yeah, I forget. I missed that. Okay, so 23 and 10. Oh, do you see the 5, 5, and 10 cancel? So we get 24. Still not 0. Is that okay, everybody? So we keep going. Plug in negative 1. We plug in negative 1. What happened? Negative 1 to the 4 is, let's see, Derica, what's negative 1 to the 4th? Negative 1 to the 4th. Huh? 1? Yes, it's 1. Negative 1 cube. Negative 1. But do you see there is a negative in front of it? So it becomes positive 5. How about negative 1 square? 1. Oh, so we get negative 5. And then negative 1 times 23 is negative 23 plus 10. Do you see the 5 cancel? And this is still not 0, right? This is negative 23 plus 11, negative 12. So it's not 0, right, everybody? So we keep going until we find 2 roots. So, okay. X equals to 2. So P of 2. Diana! What's 2 to the 4th? Yes. Yeah, 16. And then minus 5 times, what's 2 cubed? Huh? 2 cubed. So 2 times 2 is 4. 4 times 2, 8. 8 times 5? 40. So minus 40. Okay, next one. 2 square. 2 square is 4. 5 times 4. 20. So minus 20. And oh, what is 2 times 23? Yes, good job. 46 plus 10. Okay. Is it equal to 0? No. Yes or no? Yes? No. Right. So this is negative 60, right? And then this plus this is 62 and plus 10, 72. 72 minus 60 is 12, which is not 0. Keep going. So we want to use rational 0 to find 2 roots. If you're lucky, you may find the 2 roots at the beginning. If you're not lucky, you may find the roots at the very end. We don't know. We just keep trying. Okay? Haley! What's negative 2 to the 4th? Negative or positive 16? To the 4th. Positive, yes. And then negative 2 to the 3rd? Yes, negative 8. And negative 8 times negative 5? Positive 40. Good. Negative 2 squared. 4. 4 times negative 5. Yes, negative 20. And negative 2 times 23? Yes, plus 10. Oh, let's see what happened. So we get negative 66, and we also get positive 66, right? Good. We get 0. So x equals negative 2 is a root. Right, everybody? Do we stop here? Or do we continue to find more roots? Continue. Because we need to find 2 roots for degree 4. If we're doing degree 3, you find 1 root, you can stop and do the division. But this is degree 4. 1 root is not enough. You need 2 roots. So keep going. Why 2? Okay. That is because you start with degree 4. If you find 1 root and then you have, okay, let's say x equals to minus 2 is a root. That means x plus 2 is a factor, right? So you get this factor, and then the remaining is the degree 3 polynomial. How do you find the degree 3 polynomial? You still need to use rational roots theorem to find one whole root until you get the remaining is a quadratic. Because quadratic, then you can use quadratic formula. That's why before you get to degree 2, you still need to use rational zero to find the roots. That's a good question, right? Everybody? Yeah, because when you get to degree 3, you still need to find one root and then do the division. Okay, so P of 5. It came out 5 to the 4th. Oh, let's put 5 to the 4th because next you see is 5 times 5 cubed. They're the same, right? And then minus 5 times 5 squared, 25, plus 23 times 5 plus 10. Right, everybody? Okay. Do you realize this is like 23 times 5 plus 2 times 5? 10 is 2 times 5, right? And you can combine them. You get 23 plus 2 is 25. Now, do you see 25 times 5 a positive? 25 times 5 a negative? They cancel out. Yes. No, you don't have to do it that way. You can do it in your calculator, and then you get 0. I'm doing this because I didn't use calculator.
No, I'm saying like could you just multiply it all out instead of doing that? Like how
Yeah. You can do it. So it just need your calculator because that number is so big. Yeah. Is that okay, everybody? Right. Okay. You see, we get 0. Awesome. This is also a root. What does that mean? So that means our degree 4 polynomial. Negative 2 is a root. What is the factor? X plus 2 is the factor. 5 is a root. What is the factor? Yeah, x minus 5. Very good. Yeah, exactly. We put the sign. Right, everybody? Yes, this is very, very important. We put the sign. Okay. Times a quadratic factor. How do we find that quadratic factor? Okay, there are 2 ways to do that. One way is use synthetic division twice. Second way is multiply these out and you get a quadratic factor and then do long division once. Which way do you prefer? Long division once? Okay. So this is what? X times x, x squared, x times negative 5x, plus 2x. 2 times negative 5 is negative 10. Right, so this is x squared. How many x? Minus 3x minus 10. Okay, now long division. So let me do long division right here. Okay, let me move this to the left a little bit so I have more space for the long division. Okay. All right. So we have x to the 4th minus 5x cubed minus 5x squared plus 23x plus 10 divided by x squared minus 3x minus 10. Is that okay, everybody? It's like how you divide numbers. You use this polynomial divided by this quadratic factor because you want to find the quotient, right? Therefore, you put it here, and then you look at the leading term. What multiply by x squared to get x to the fourth? X squared, right? Oops, I asked you x squared. X squared times x squared is? Yeah, x squared times negative 3x. Negative 3x to the third, right? X squared times negative 10. Yeah. Okay, use the first line, subtract the second line. X to the fourth minus x to the fourth, 0. Negative 5x cubed minus negative 3x cubed is what? That 2x cubed. Yes. Positive or negative? Negative 2x cubed. And negative 5x squared minus negative 10x squared is negative or positive? Positive, yes. Okay, plus 23x plus 10. Okay, Jackson. What multiplied by x squared to get negative 2x cubed? Minus 2x. So minus 2x times x squared is negative 2x cubed. Negative 2x times negative 3x. Uh, so we use this term to multiply by all these three terms, right? So negative 2x times negative 3x is times. 2 times 3? 6. And negative negative cancel, right? So 6x squared. Okay. Minus 2x times minus 10. Minus 2x times minus 10. Multiply. Minus 2x times minus 10. Plus 20x. Yes. So we multiply. Okay. Do you see we use first line, so the second line, this cancel, right? Okay, what is 5x squared minus 6x squared? Do you, Jackson? Negative x squared. 23x minus 20x? Yeah. And then we have the 10 left, right? Thank you. Okay, even. What do we multiply now? X squared times what is negative x squared? Yes. And when you multiply negative 1, what do you get?
Negative x squared.
Mm-hmm.
And when you do positive 3x,
Mm-hmm.
you do a positive.
Oh, do you see what's the remainder? 0. That's always the case. Because p of x has this factor, the remainder should be 0. Good. So we have what? We have this remaining quadratic factor is x squared minus 2x minus 1. Okay, everybody? So, can we factor further? Can we factor further? Not quite, because minus 1 won't give you the mean of minus 2. Okay? So, let's use quadratic formula. Okay, everybody? So, especially those of you who are not good at factoring. Quadratic formula. So, x equals what? Negative b. What's b? Negative 2. So negative b is 2. Plus or minus b squared. Negative 2 squared minus 4, 1. Yeah, 4ac over 2 times 1. Good job. Okay. What's negative 2 squared? 4 minus negative becomes 4. 4 plus 4. 8. Do you know square root of 8 is 2 root 2? Yes, everybody? Okay. Do you see the numerator, those two terms? We have a common factor 2? Yes. Factor out 2. What's left? 1 plus or minus square root of 2. Yes? Now we can cancel the 2. We get 1 plus or minus square root of 2. Okay, everybody? Yes. Right. And do you see this is an irrational number? This is an irrational number.
Why do we need to do this?
Oh, because we're not able to factor it. So when you solve quadratic functions, you either use factor methods, okay, or you use the quadratic formula.
How do we find x squared minus 2x minus 1?
Oh, long
Oh, just
division.
doing that up there?
Yeah, that's the quotient, right? Yeah. So that's the remaining quadratic factor. So now what are the roots? The roots are, see, the roots are -2 and 5 and 1 plus or minus square root of 2. We have 4 roots. All of them has multiplicity 1. Is that okay, everybody? Because it's a factorization. That power raised to the power 1. Okay, so all of them has multiplicity 1. So far, so good? So this is a good example because now we see our roots is not always rational. So students, if you go ahead, okay, now we try 1, 2, 3, 4, 5, 5 numbers. But in this list, we have 8 numbers. So even though you try the remaining 3 numbers, you won't find more roots. Okay? Because this polynomial, we only have 2 rational zeros. This is from the list. Okay? So the rational zero theorem can only help us to find rational roots. It cannot help us to find irrational roots or complex roots. Okay, everybody? So you use the rational root theorem to find 2 roots for degree 4 polynomial. Then you use long division to find the remaining quadratic factor. And then you can use the quadratic formula to find the remaining 2 roots. Is that clear, everybody? Mm-hmm. Good. And sometimes it might happen that if your polynomial is like x minus 1 cubed 2x plus 1, if you have something like this, yes, it has all the rational roots, but this rational root has multiplicity 3. Okay? Using the rational root theorem, you can only see, oh, x minus 1 and 2x plus 1. You only get 2 roots. But you can use the long division and then to find the remaining quadratic factor, and then you realize, oh, let's say the remaining quadratic factor looks like this. Then you will see, oh, this one I can factor it as x minus 1 squared, and this is the same as this. We can combine them and get x minus 1 raised to the power 3. Okay? So the rational zero theorem, it cannot tell you the multiplicity. Is that okay, everybody? It can tell you, oh, one is a root, negative 1/2 is a root, but it won't tell you whether this root is repeated. So this root is like repeated 3 times. Okay, so in order to show the multiplicity, you still need to use the long division to find the remaining quadratic factor. Then you can recognize, oh, this root is in fact has multiplicity 3. Okay. All right, so this is the rational zero theorem. And I would say on your exam, you won't see complex roots. Okay, so you only see either rational roots or irrational roots. But complex roots work similarly. Instead of here you go. After 2, maybe you get -2. Then you know square root of -1 is the I, right? Do you know the square root of -1 is I? Yes, yes. Okay. Right. But on your exam, I won't test you on the complex numbers. Okay. So this is everything we learned for exam 2. Okay. All right. How about now? Take out your exam formula sheets. Let's fill this out together. Also like a review, right? Okay. So exam 2 formula sheets. Yeah, exam 1. you fill it out by yourself. Okay. Yeah. Now take out the exam 2 formula sheets. Okay. So everybody stand up. Everybody stand up. Math exercise. Math exercise. Stand up. Stand up. Okay, ready? Move your head. Everybody stand up. Line. X squared. X cubed. Square root. Square root. Cube root. Absolute value. Absolute value. Like that, right? Okay. How about order of transmission? Order of transmissions. The first one. Left, right. Okay, let's do that. Move your hand. Left, right. Second one. Flip over the. Okay, let's do that. Yes? Yes? Let's do that. Move your leg. Step 3.
Shift over egg, reflex.
We flip over exit. Let's do that. Let's do that. Hey, your muscle. You let your muscle memorize it. And how about the other one? Vertical stretch. Let's do that. Okay? Stretch. And then the last one. Up and down, up, down, up, down. Okay. So you do the math exercise every day. Okay. Now, not only we need the shape, but also the key points. Label the key points. So for x squared, the key point is what? 0, 0, 0, 1, 1, 2, 2, what? Yeah, 4. So please label the key points. So this is -1, 1, and this is -2, 4. And then you connect them. So we have 5 key points for x squared. Everybody clear? So on your picture, I want 5 key points, okay? X cubed. What are the key points? 0, 0, 1, 1, 2, 8. So 1, 2, 3, 4, 5, 6, 7, 8. -1, what? -1, -1. -2, -8, right? 1, 2, 3, 4, 5, 6, 7, 8. And then we connect them together. Boom. Okay. How many key points do we have? 5. Write it down on your sheet. Okay. Square roots. What are the key points? 0, 0, and 1, 1, and 2. Do you do square root of 2? No. 4, 2. Exactly. 4, 2. How many key points? 3. Only 3 for square root of x. everybody? Okay, keep going. How about key roots? Key roots 0, 0, and 1, 1, and key root of what number is an integer? 8. Yes, key root of 8 is 2. So 1, 2, 3, 4, 5, 6, 7, 8. 8. And the y coordinate is 2. On the other hand, on the other side, -1, you get what? -1. And also -8, you get what? -2. Good. So you connect them. So how many key points here? 5. Okay, everybody? 5 key points. Absolute value of x. 0, 0. And then 1, 1. 2, 2. You know, absolute value is gonna be like a V shape, right? Lines, right? So 1, 1 is enough, and also -1, -1. So that's enough. Okay. So you just need 3 key points for absolute value of x. Is that okay, everybody? So on your exam, you will have one of these. So 5. Okay, 5 choice. You have one of these. And then you do the transformations. So everybody finished this part? Yes? Okay. Order of transformation. What's the first one? Yeah. Move, move, move. Okay, let your muscle get used to it. Shift. Left or right? Okay. And left is what? Which one is positive? Left is positive. Right is negative. So how do you change your coordinates? Yeah. Yes. You're changing your x. Okay. And your y remain the same. Right, everybody? Okay. Second one. Yeah, we read about the y. So we read about the y-axis. Do you change the x or you change the y? Yes. And you put a negative sign in front of x. Very good. The third one. Yes. We read about the x-axis. What do you change? Y. So you have a minus sign in front of the whole function. Right, everybody? Okay, and then what? What else? Yeah, vertical stretch by a factor of c, okay? And then which one do you change, x or y? Y. And you put a c multiplied by the y. Right, everybody? Yes, c times y. This is time. Okay, last one. Yeah, shift up or down. And you're changing the x or y? The y. So y plus or minus c. Is that clear, everybody? Okay, to find the domain, if you see square roots, what do you need? Greater than or equal to 0, right? If you see fraction, what do you need? Not equal to 0. Right, everybody? That's the domain. That's how we find the domain. Okay, quadratic equation. We want to convert from the general form y equals ax squared plus bx plus c to the vertex form y equals a times x minus h, parentheses. squared plus k. This is the vertex form, or we say standard. Okay? What's the vertex? HK. And make sure you remember the vertex form, even though I don't have you to fill it out, but remember that. Acid of symmetry. X equals H. Okay? So you find your vertex, HK, and then depends on your A. If your A is positive, then opens up. Okay? If A is negative, open down. So your acid of symmetry is this line, X equals H. Okay, everybody? It's not just H. It's a line. So line equation, X equals H. How do you find H? B over negative 2A. Right? Then we need to know that. If you're giving the general form, how do you get the vertex form? H is B over negative 2A. Okay, everybody? What's your K? F of H. So you plug H into the formula. This is the K. Okay, everybody? So make sure remember this. And then here I show you the set of graphing polynomial functions, and I show you the set of solving polynomial inequalities. Be careful, everybody. I have a typo. So if you have greater than or equal to or less than or equal to, you draw a closed circle, a solid circle. If the left hand side is fraction, draw a closed circle on numerator roots and draw open. On your notes, we have a typo. I put a solid, right?
Yeah.
Yeah. So correct that typo, change to open circle. Your denominator cannot be 0, so your denominator root is always open circle. Okay, so yeah, yeah. Peter, try this out. Thank you, Peter. Yeah, open circle here. And if you see greater than or less than, always open circles. And in the exam, because we don't have enough time, I will only ask you polynomial degree 3. Okay, so you won't see the degree 4 case. So you use the rational root theorem to find one root. Then you use the long division or synthetic division. I would say synthetic division is easier if you're familiar with that. And please write down the quadratic formula. What's quadratic formula? Yes. Okay. Good. So have a nice day. So I hope to see you in my office hours weekly.
So am I good to take the exam on Wednesday?
Yes.
Okay.
Yes.
What time do you want me to take that?
Do you have time like from so either 12:45 to
Okay,
1:45?
Yeah, that's good because
Oh.
my last class is an 11 to 12, so that's fine.
Oh,
So
okay.
12:45 on Wednesday.
Yes. 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 Perfect.